In section 2.7, we're going to talk about measures of the spread of the data. The technical term for that would be the measures of variation of the data. So basically, do we have data that all tends to be pretty close to the mean, or is our data all spread out? So we have some values that are close, some values that are far away. That's how much variation is in the data. The most important, most significant, most frequently used statistic for variation is the standard deviation. Okay, it's just a way that tells us how far the typical data value is from the mean. It does a couple of important things. It gives us an overall measure for the total amount of variation that's in a data set, but it can also be used to give us an idea on a particular data value to kind of determine, is this value normal, or does this value seem to be kind of strange? The standard deviation is a way that we can make that determination. In general, we're never going to have negative standard deviations. We just consider it to be a positive value all the time. If you have a data value that, or if you have a data set that's all the same number, like say you just have a sample size of 20 and all 20 numbers are the same, then your standard deviation will be 0 because there is no variation. They're all the same. Otherwise, your standard deviation will typically be a positive number. We don't deal with negative standard deviations. If you have values that are all pretty close to the mean, then your standard deviation will be small. If your data is very spread out, then your standard deviation will be larger. So for example, if you have supermarket A that has a mean wait time at the checkout counter of 5 minutes and a standard deviation of 2 minutes versus supermarket B that has the same mean wait time but has a larger standard deviation, what that means is you can expect a pretty consistent experience at supermarket A because their standard deviation is low. You're going to wait about 5 minutes. It's going to be pretty consistent. But at supermarket B, the average is still 5 minutes, but you could have some people that are getting in and out of there in 1 minute, and you can have other people that are taking up to 9 minutes, as sort of a normal pattern of behavior. And so that larger variation means that your experience would not be quite as consistent from time to time, from visit to visit. So that doesn't necessarily equate to good or bad, but it's certainly something to kind of think about. High standard deviations mean things are not quite as consistent. So suppose these two gentlemen shop at supermarket A. Jim Bob waits for 7 minutes. That means that his wait time is 2 minutes longer than the mean. But remember that at supermarket A, the standard deviation was 2 minutes. So his wait is 1 standard deviation longer than the mean. And then we have Billy Ray, who waits for 1 minute. His wait time is 4 minutes shorter than the mean, which equates to 2 standard deviations shorter than the mean. Remember, the standard deviation was 2. So what does this mean exactly? Basically, what I want you to take away from this is that the first visitor, Jim Bob, he had a pretty normal experience. Okay, a standard deviation, having an experience that is 1 standard deviation different from the mean is not at all unusual. Okay, a great number of visits from people here would be within 1 standard deviation of the mean. Okay, Billy Ray, on the other hand, he had a great experience because it was quick, but it was a little bit unusual. Okay, because he was 2 standard deviations shorter than the mean, meaning that that not very many of those short 1-minute visits are likely to happen. Okay, so the more standard deviations away you are from the mean, the less likely that is to happen, so the fewer of those things there are. So how do we calculate standard deviation? Well, there are 2 formulas for standard deviation. One of them is for the standard deviation of a sample, and the other is for the standard deviation of a population. So you have to know the context of the data you're looking at in order to know which one you're looking for, which one to find. So one of the things that's important to point out, we don't do a lot of work with the variance in this class. Variance is something that comes up if you take more advanced statistics classes at some point in the future. But the variance is the average of the squares of the deviations. So variance is literally the standard deviation squared, or you could say it as the standard deviation is the square root of the variance. Okay, whichever way you want to phrase that. So it's just kind of an important connection to make. So the symbol for variance is, if you're dealing with a population, sigma squared. If you're dealing with a sample, it's s squared. All right, so the standard deviation for a sample is abbreviated with an S. The standard deviation for a population is abbreviated with this funny looking symbol that is actually a sigma, a lowercase Greek letter sigma. And these are the two formulas that we use depending on whether we're looking for a sample or a population. Now the good news is I am not going to make you calculate standard deviation by hand, so you don't actually have to memorize these formulas. That's not really the purpose of this course. It's kind of good to have an idea of how this works, and if you really have the initiative, you want to try calculating one of these by hand, or if maybe you want me to do it during office hours, just to kind of show you, we could do that. But the calculation can be pretty tedious, especially when the sample size gets pretty large. So here are the formulas, but I will show you how to find them in the calculator in just a moment. In fact, here we are. So the OneVar Stats menu is a super helpful menu. It says here that we looked at it last class, but I think this was written when we were in class, not during a summer session, so we obviously didn't look at it last class. So in the example here in a minute, we're going to look at the standard deviation for a sample. I'm going to point out where the standard deviation can be found for the population. And again, just keep in mind that you need to know which one you're looking for depending on the context of the question. All right, so here's our data for example number 1. You may want to jot these down or go ahead and start putting these in the calculator. I'm going to switch over to my calculator view so that we can walk through this example.
All right, I want to show you guys one of the most valuable tools that we have here for stats in the calculator, and that's the OneVar Stats function. Okay, so right after, you should be viewing this right after seeing the data for example number 1. And so we want to put that data into our L1 list again. So hit the Stat button, which takes you to this menu, and then we want to pick Edit, which is the very first option. And then you type your data in case that wasn't clear on a previous video. Type the number that you want, hit Enter, type the next number that you want, hit Enter, and it'll put all the data in. If you have some data in there already and you want to get rid of it, the easiest way to do that is to hit the up arrow to highlight L1, and then hit Clear and Enter, and it'll just completely clear that list so you can start fresh. All right, so go ahead and take the time to do that, and then once you have all your data into L1, you can find a lot of really useful statistics by hitting the Stat button and then hitting the right arrow key once to go over to the Calc menu, and then OneVar Stats, the first option there, gives us a lot of good stuff. We tell it which list we want, which should be L1. We can leave the frequency list blank because we've just put in all the raw data on this one. If you type in a frequency table, then you can put the left-hand column here, put the frequencies in the L2, and then tell it L2. I'll show you how to do that at a later date. We don't need it for now, but hit Calculate, and it gives us some pretty useful information. Right off the bat, we see the X bar is the first line. Okay, that's the sample mean. But what we're talking about today is the standard deviation, which in this case, because we're talking about a sample standard deviation, we want to look for SX. Okay, S is the symbol that we use for sample standard deviation. So 0.71589, yada yada, is what you should get for that. Now, if this was a population and we were looking for the population standard deviation, that would be the next line. Sigma X gives us a population standard deviation. Notice that these two numbers are different because the formulas are different. But in this context, we want the sample standard deviation, so we're looking for that first line.
All right, to continue with example number one, now that we have looked at the calculator and found the mean and the standard deviation, just to refresh, I think we found, I'm doing this from memory, I think we found the mean was 10.525 and the standard deviation was 0.7198, I think. We want to find the value that is one standard deviation above the mean. So with a mean of 10.525 and a standard deviation of 0.7198, we add and we should get 11.24. Again, I'm going to round it there. You could go further, but I think that's fine. Because remember, our data had one decimal place, and typically we want to give one more decimal place than the original data had, so that would be 11.24 in this case. And then for our third little question here, the value that would be two standard deviations below the mean, that would be 10.525 minus 0.7198 times 2. Okay, so that should give you 9.09. That's what I got, so hopefully you can do that calculation and verify that. And then the last one here, I want you to do this one on your own. If you have any questions about it, we can hit that during office hours. Alright, so Chebyshev is the name of a guy who did quite a lot of work involving statistics and probability and normal distributions and all kinds of good stuff. So we have a rule that we get from Chebyshev that says that at least 75% of the data is within 2 standard deviations of the mean, at least 89% is within 3, and at least 95% is within 4.5 standard deviations of the mean. Now, in practice, it's usually a lot more than that. Okay, and notice it says at least 75%, at least 89%. Chebyshev identified limits in the calculations where we're not going to be able to see any data set ever where there's not less than 75% of the data within 2 standard deviations of the mean. It has to happen that way. So we call it Chebyshev's rule. Now, like I said, in practice, it's usually a lot more than that. Okay, and in particular, if we have a symmetric distribution, we can ramp it up to the empirical rule. Okay, which says that 68% of the data, about 68% of the data will be within 1 standard deviation. About 95% will be within 2. Remember, that's increased quite a bit from Chebyshev, where he said, notice that first one, he said 75% will be within 2 standard deviations. Now we're at 95% will be within 2 standard deviations. And then lastly, 99% of the data will be within 3 standard deviations. So remember, this rule only works if you have a symmetric distribution. So your data has to be bell-shaped on the histogram. If it's not bell-shaped on the histogram, then we can't rely on the empirical rule. We'd have to go back to Chebyshev. All right, for the homework in this section, you're going to be finding some standard deviations. You're going to be, finding the value that is 2 standard deviations above or 3 standard deviations below. Those kind of calculations in this practice set. So let me know if you have any questions, and thank you. This concludes Chapter 2. So make sure that you have your questions ready before our Chapters 1 and 2 quiz. Thank you very much.